Robotics is one of the big bets that TRI is placing for the future. The reason why we're investing so heavily in robotics is the potential to address big challenges that are facing society, in particular, the megatrend of aging society.
How do you articulate the problem that is going to push the technology towards that long-term vision? And the strategy we've taken for that is to find these challenge problems and clearly define tasks that are beyond the state-of-the-art capabilities that will force us to grow our core capabilities towards that long-term challenge. For instance, the team I work with here that's doing dexterous manipulation, we decided that food preparation we could form a grand challenge out of.
As a group, we're looking at something much bigger than pizza making or even just food. Right now, my group is working on generating the individual skills. How do we make cuts? How do we make doughs? How do we spread sauce? We're not just focused on pizza making. We're actually looking at a generalized pipeline that can generate skills and generate tasks for all kinds of different applications. It's very conceivable we'll extend the approach to things like laundry folding, to tidying up, or even in the factory lines.
One of our challenges is making all of these individual bits of machine learning work together and be flexible enough that they can improve themselves over time. And as we add new tasks and we add new capabilities, we can take advantage of what we had before, and then we can just continue to improve the robot instead of starting over from scratch.
We do challenge tasks to try to apply what we think a solution might be to a real application. So for example, if our challenge task is grocery shopping and our robot needs to go and figure out how is it going to identify the right box of cereal to pull off of the shelf and safely put it in the basket without damaging anything or itself or anyone around it, we can take what we've learned with that and apply it in a factory environment. How do we pluck the right part at the right time and put it in the right place safely and reliably every time?
Toyota is obviously a huge manufacturing company, so I think that provides several different potential ways to take advantage of that. Another potential aspect is using Toyota manufacturing to actually build robots for us. Robotics and mobile manipulators specifically can have the potential to operate in human environments like no other robot in the past and potentially provide value to people's daily lives.
Robotics definitely has the ability to amplify people's abilities, but applying it to a problem, a real-world problem, and actually helping people, that's where I think technology can really benefit people. So the problem that we've chosen is really about helping older adults in the home with their mobility and stability. Typically in machine learning, a large amount of data is actually required in order for these algorithms to learn whatever task is in front of them. And in this case, we're actually looking at a very specialty use case where we have these very expert people who have this medical knowledge and training. From there, we can use that information to then think about, well, how can the robot then act in the role of the caregiver? How should the robot move its own physical body in order to provide the support that the care receiver needs?
We believe that soft robotics is going to be very important for allowing robots to operate in the same space as people. It will be easier to do certain things that require large-scale manipulation, picking up boxes that have a dynamic property, or if you're co-working with humans, maybe the human is going to perturb or add something to the box that the robot is holding, or try to help the robot. I get really excited about how we might use this toward domestic environments where people will actually see this technology and start to use this, and it can actually benefit people to have a robot like this in their home and grow with the human and learn how to interact with humans.